Algebra.
Stop talking. Can we stop talking?
Zoe, Josie, we have begun. Nolan, I'm doing this for you just as a test. Okay, just make sure the buttons work, just in case. So, the homework that you needed to do for today was to write expressions in expanded form and then simplify them. And recall that by simplifying, we meant combine all coefficients, girls, and combine all like bases. Okay. Now, if you kind of look ahead to see what your homework for tonight's going to be, you notice that the exponents get a little bit bigger, right? Here we have x to the 11th. Here we have n to the 8th times 9 more times 3 more times 1 more. Here we have 10 and 13. And I didn't really give you that much more space to write than I did on this page here. Okay. That's because now that we've had a couple days diving into expanded form, I don't want you to use it anymore. Can you use expanded form? Yes, but there's a much more efficient and speedy way to simplify these exponent expressions that involves using a pattern. Remember, I've talked to algebra being all about patterns. A pattern or a rule. And the best part is, this can go on a help sheet. Okay? So I want you to go back up to the top, and you should have these notes down here from yesterday. Right? I'm going to remind you just a little bit what happened here. This is 3 to the 4th times 3 to the 1st. Even though it's not written, there's a power of 1 there. And our answer was 3 to the 5th. The second one, 7y cubed times y to the 4th. We kept the 7, and then our exponent was y to the 7th. In the last one, we multiplied 8 and 5 to get 40. X cubed y to the 5th. And here's my question. Okay, and some of you probably noticed this developing as you were doing your homework yesterday, looking at expanded form, looking where you started, looking at your final answer. If you are multiplying by the same base, which we are here, essentially what happens to the coefficients? What did we do with 8 and 5? What did we do with 10 and 14? What did we do with 7 and 2? What did we do with them? Zoe, we multiply them. Okay? And that's true for any time you are combining exponent expressions by multiplying by the same base. Your coefficients always get multiplied. Now, in your head, if you're thinking, what's a coefficient? Go back to PO9. We defined them all. And that was why I said, for PO9, it's important that you know these definitions, because when we talk about them, when we use them, you've got to know what we're referring to. Okay? How about the exponents? How did 4 and 1 make 5 and 3 to the 5th? How did y cubed and y to the 4th give us y to the 7th?
You just add them.
You just add them. Exactly. Okay? The exponents, you'll notice, are simply added. And in expanded form, it's very clear why that is. Let's take our 7y cubed times y to the 4th. We have 7. Y cubed is 3y's. Right? We have 3 of them. We get 4 more. 1, 2, 3, 4, 5, 6, 7. 3 plus 4 is 7. You don't have to go to expanded form anymore because we have this rule, this shortcut, this pattern. And finally, the base. 3 to the 4th times 3 to the 5th. Girls, I'm going to ask you again, stop. Done. Or take your seat in the back, Zoe. Okay. When we got down for this one, this 10 cubed times 10 squared, our answer was 10 to the 5th. Not 100, 10 to the 5th. 6 squared times 6 cubed, 6 to the 5th. Not 36, 6 to the 5th. Right? What happens to our bases? Did anything change when we had a base of 3 and our final answer had a base of 3? Did anything change when we had a base of 6, our final answer had a base of 6? Did anything change with our 10s here? No. The bases stay the same. The base stays the same. Okay? And that's why it's important to understand the difference, especially between a base and a coefficient. Because coefficients can only be numbers, but bases can be numbers too. And when it's a numerical base, it doesn't change. When it's a coefficient, you multiply it. Adrian.
Never mind. My question got answered.
Excellent. Okay? Back on the help sheet. Okay? And armed with this rule, you now have the ability to do the second page much more quickly than the first one, because as the directions say, the goal here is to not have to write the expression in expanded form. Instead, speed up the process by using the rule. So the first one there, n to the fourth times n to the sixth. What's your simplified answer going to be? Landon?
And 11.
Not 11.
Oh, I
How'd you get 11?
and 10.
N to the 10th. Okay? There are no coefficients, so nothing to multiply. Our base of n stays an n, nothing changes. And then our exponents, 4 plus 6, get added. That gives us 10. We're done.
Oh.
Okay?
Oh.
Now, if you forget the rule, can you use expanded form? Sure, you can write out n times n times n times n. There's our n to the fourth. Times n times n times n times n times n times n. There's n to the sixth. You can count them up. You can see that there's 10 there, right? But if you know that the exponents just get added anyway, it's a much more efficient process. Okay? Adrian.
I'll get answer the next one.
Fantastic, Adrian. What you come up with?
X to the 7th.
X to the 7th is correct. Okay? 5 plus 2. Right? Again, no coefficients here. Question or answer? I'm only taking questions now because we're going to go on to the next row where they get a little more complicated. But okay. Which one would you like to do together on row number 2? Third one? Very well. So third one, you've got 3 terms here. Negative 3y to the 6th times 2y times negative 4y to the 9th. Do we have coefficients? Those numbers before the base. Yes, we do. What are they? Dominic.
Negative 3, 2, and negative 4.
Negative 3, 2, and negative 4. What do we do with the coefficients according to the rule? William. What do we do with the coefficients according to the rule? No, he's thinking, and you will let him think in peace. If he's unsure, he can check the rule on the page prior. Look where we said coefficients, and what did you write down? You multiply them, right? So these coefficients, negative 3 times 2 times negative 4, they get multiplied, and that gives us positive 24. Note it's positive because you do have a negative times a negative in there, right? That makes it positive. Raise your hand. Tell me what the base is. What is the base? Raise your hand.
No, what? Raise your hand.
It is y. Okay. The base doesn't change, right? Still going to be a y. And how many of them do we have in all there? Don't forget, there's that invisible 1 there that's not written, but there it is. How many y's do we have total, Josie? 16. 6 plus 1 plus 9 is 16. Coefficients multiply, bases stay the same, exponents added. Okay? Pick one on in the third row that you want to go over, talk about. Dominic.
The last one.
The last one. All right. Do we have coefficients? Let's get someone we haven't heard from yet today. Do we have coefficients in the last 8x to the 5th y squared times negative 7x to the 10th y to the 13th? Anthony?
What?
Are there coefficients there?
Where?
In the last one?
Oh, last problem?
Yeah.
Yeah.
Yeah, there are. What are they?
8 and 7.
8 and
7.
and
Negative 7.
negative 7. Okay? And then negative sign matters, right? Because when you multiply them, a positive times a negative is going to give you a negative result, negative 56. Okay? Then with our bases, we have x to the 5th and x to the 10th. How many x's do we have in all, Peyton?
Sorry. What?
I forgive you. We have x to the 5th and x to the 10th. How many x's do we have in all? No?
X to the 10th, X to the 5th. Oh, 15.
15, right? Think about what that means in expanded form. X to the 15th. And then y squared and y to the 13th. what happens to those powers? How many y's do we have, Aiden?
15.
15. Very good. See how much nicer this is than using expanded form? Okay? Expanded form is great because it does explain how we get to these answers, right? But it's much more efficient to use the rule. And that's why the rule can go on a help sheet, and that's why that's what I'd like you to use. Okay? The bottom part of the page, we kind of go in reverse here. I tell you that some equation equals n to the 11th. So you know that we should have a total of 11 n's. If 5 of them are there, what's the missing exponent? Dominic? 6, because n to the 6th times n to the 5th, 6 plus 5, equals n to the 11th. Right? So in that section, you are filling in the missing box, the empty square with the exponent that should go there. Questions, comments, concerns, complaints, comments, congratulations, criticisms on CO10. Homework for tomorrow is the rest of the page. We have one doubter in the room that doesn't believe we can do it. Let us prove him wrong.
You guys can't.
We shall laugh in his face tomorrow as we celebrate point number 2. All right? All right. That's how you math, folks.
Okay, don't come back like